everyone. Welcome to GTC 2021 Lanner AGI Inference and NGC Ready Server hardware perspective talk. Thank you for joining our talk. And before we start this presentation, I'd like to remind you that we are available for chat during the talk. So as any question come up, please click on chat button on the bottom right of the web browser to submit your question. So let's get started with the speaker's bio. So introduction about myself and co-host Abhinav. So I'll start first. My name is Mauli Kupala. I am AI and Deep Learning Product and Market Development Manager at Lanner. I'm responsible for developing AGI product concept, strategies, marketing initiative, decomposite go-to-market plans, and analyzing AGI market trend. Prior to joining Lanner, I was part of Intel IoTG group, and I was working as a platform engineer, a platform application engineering lead at Intel. And the key focus areas were out-of-band manageability, virtualization, and AI technologies. I'll pass it over to Abhinav. Abhinav, go ahead and introduce yourself.
My name is Abhinav. I run product and engineering at Zippin. Zippin is an AI startup that provides checkout-free technology to retailers. I've been working with multiple companies in this space, US sports stadiums to other grocery chain retailers, to bring frictionless shopping to their stores. Before joining Zippin, I was at VMware building different cloud infrastructure solutions and services. I have a bachelor's degree in computer science from IIT Roorkee.
Thank you, Abhinav. So let's have a look at the agenda of our talk today. So our talking point about introduction to Lanner and Zippin, what we do, what are our offerings, and how we go to market. Then we talk about explosion of AGI and deep learning inference challenges. Following up with Lanner GPU product offerings, introduction to NVIDIA NGC Ready Servers. Lanner NGC Ready Server, we have certain programs, so I'll talk about those programs, and Abhinav will give deep dive to retail AGI use case. So let's understand more about Lanner. So Lanner is a global company, headquarters in Taiwan. We have a global presence, as I mentioned. We have local subsidiaries around the world as well, third-party logistics centers, technical support centers, and etc. We founded in 1986. We are leading hardware provider of network computing, telecommunication, and intelligent edge appliances. We've been seeing a solid continuous growth in past 10 years with 16% of annual growth rate. A major subset of our employees focus particularly on manufacturing and R&D in-house, since we do not leverage third-party contract manufacturers. So whatever happens happens inside the Lanner fabrication labs. Then our new growth engines are AI, 5G technology, SD-WAN, and IoT. Our system manufacturing is basically following top-notch quality, environmental health and safety, and security certification criteria for system manufacturing. So that's a quick introduction about Lanner. Now let's understand more about Lanner competencies of edge system manufacturing. Since this talk is about edge AI, so I would like to shed some light on Lanner's competency and competitive advantage of hardware availability for innovative technology, symbiotic partnership, and globally at local subsidiaries. So we have 30 years of ODM and OEM experience with long-term relationship and partnership. We provide system-level integration, that is purely integrated design in services. So as I mentioned, we do design and manufacture in-house. We also offer custom branding, motherboard I/O, and peripheral customization option as well. And we have offerings of value-added services, which is basic. I think I skipped the slide. Yeah, so which is basically providing pre-configuration of our partner solution, then inventory management and drop shipment for our partner. So for edge computing, we have four vertical market focus. That is general purpose embedded computing, smart transportation, industrial IoT and cybersecurity systems, and energy edge. And for us, AI is a horizontal focus for all vertical market, and we carry certain competency in that market. For those vertical markets, such as for industrial computing, we brand and manufacture hardware which comes with the industrial grade standard compact form factor PCs, which offers the PCI expansion for modularity if our partners or customer would like to leverage discrete GPUs or other kind of AI accelerator cards. Then for transportation, we have a wide temperature, robust in-vehicle computers. And those comes with the, as I mentioned, wide temperature range, and it comes with the quality certification, which is military grade vibration. For industrial IoT, we have a small form factor gateways. So those are again vibration. It offers the wide temperature range and the power isolation option, etc. And same for energy edge market, we have a hardware which offers flexible IO selection. So that is a quick sneak peek of our hardware offering in certain market. And going to next slide, I would like to Abhinav to introduce Zipin. So Abhinav, over to you.
Thank you, Malik. On the Zipin, we provide checkout-free platform for physical stores. Malik, if you can go to next slide.
Oh yeah, sure.
Okay. We'll go over the kind of our architecture and technical details later in this presentation. For now, I want to introduce what Zipin does, what checkout-free platform is. It is helping retailers to build their store of the future. What do I mean by that? Retailers are looking to provide a convenient way and safe environment for their shoppers. They want to get more and more analytics. So we have seen in past, in general, that analytics for brick and mortar stores is limited to POS. In this case, they're looking for more granular, not just when things are bought, but also what shoppers are doing inside the store. And the third pain point in general is efficient inventory management, because at any point of time, if shoppers can't find items, retailers are losing their sales, shoppers are not happy. So Zipin's checkout-free platform hits on to these pain points. How do we do it? Most of the store operations are automated if you're using our checkout-free platform. That means lower labor costs, and your store crew or store employees can focus on customer service, the things that they like, rather than kind of checking them out. Also, given that it is checkout free, which means you are using your space in a much better way, and you can handle higher traffic. So you're not limited by how many cashiers you have. That kind of translates to higher sales per square feet. And the third point here on the streamlined inventory ops. So you have real-time view of your inventory for every shelf. And you get your real-time alerts as well if something is running out or out of stock, right? When you get that, you can also scan your inventory much faster. Basically, you're not doing anything. You're not scanning it. Our system automatically figures out when your store crew is kind of restocking items. So you can do much faster restocking, right? And you're reducing the time when inventory is not available, which means retailers can sell more, as well as shoppers are happy because they're finding the products that they want. Advanced analytics, think about our technology is like a browser cookie for physical stores. So in general, as I mentioned earlier, in physical stores, analytics was limited to POS systems, because that's when you know what got bought and what is not, right? But in this technology, what we have done is we pretty much give you visibility into what shoppers are doing inside the store, the kind of analytics that was not possible before checkout free technology. Given that we have cameras, sensors, and kind of figuring out what people are shopping, what they're doing in the store, also helps with fewer losses, because there is no theft. Everything is being viewed in real time. So people don't tend to kind of try to hide stuff, right? And that means fewer losses due to theft. It also means a lower shrink. In general, you can think retailers are providing a delightful experience to their customers and improving their business models. Go to the next slide, Malik. Zippin is already powering physical stores, brick and mortar stores around the globe. You can see the technology is already trusted by our customers and partners, like Sacramento Kings, that's a stadium store in US, Aramark, Microsoft. In Japan, we have partnered with Fujitsu. They're reselling this solution to retailers there. Lawson, Koyo Group are few of the retailers. In Brazil, we have a partner with Lojas, and Europe, in partnership with the Sberbank and Visa, we are launching it to multiple stores. Some of these stores are actually opened, as you can see the date, during last year, during pandemics, around 50% of that. All right.
All right. Thank you so much, Abhinav, for a quick introduction about Zippin and what you guys do. So let's understand how AI is revolutionizing every industry. So starting from industrial. So for industrial, we've been seeing predictive maintenance and machine vision, AI-powered machine vision application. For retail, as Abhinav mentioned, checkout free technology is one of the great way to provide next generation customer experience. Then smart cities and definitely health and education. So these are the top industry taking advantage of new generation of technology, which is powered by AI. And we've been seeing solid growth in the software revenue, and which is about to reach 100 billion in by 2025. That will create 13 trillion additional economic activity as per Forbes, and it will also create new jobs. But this all this revolutionization and introduction to new application comes with challenges. And particularly when we talk about edge AI, deep learning is key element of edge AI, right? And there are certain challenges involved with inference application segments, right? And those challenges are basically increasing size and complexity of deep neural network, as we all know. Then demand of multi-precision network for different use cases depending on the accuracy and latency trade-offs we've been seeing. Then high volume and low latency inference throughput is required nowadays, particularly when you're leveraging convolutional neural network, right? And another one is need of IT infrastructure to deploy this workflow. So these are the very generic challenges. And when you use GPU for edge AI as AI acceleration, then there are another set of challenge, right? Which is how whether those GPU systems you are leveraging, which are tested and validated for performance of deep learning framework or machine learning or inference library. So IT folks can easily deploy those workloads, right? So how NVIDIA and Lanner worked out together to address those challenges. We'll talk about more on that in next slide. But before that, I would like to introduce Lanner GPU product offering. So what we have for NVIDIA GPU market, or how our partners or customer can use our hardware. So we have two segments for that. The first, on the left hand side, you can see we have a super edge appliances, which can be used at the extreme edge. And those appliances are powered by Tesla T4 GPU. So we have appliance for that called LEC2290, which is an NGC Ready Server for Edge AI. And then we are manufacturing NVIDIA Jetson NX-based Edge AI inference appliance as well. On the right-hand side, you see our rack mount appliances such as FX3420, which can accommodate up to 3 T4 GPU, and which is a hyper-converged multi-access edge computing appliance. Then we have NVIDIA A100 GPU-powered appliance called ECA4026, which is edge compute appliance for private edge clouds, where you want to do high compute deep learning training. You can leverage this appliance. And on top of that, we have 1U rack mount appliance, which comes with our NCS2 form factor video transcoding card, so which can fit up to 8 TX2 Jetson modules inside for video transcoding. And there are other scale-up modules available up to 16 TX2. So we have some option for that. So now let's understand how, as I mentioned, the inference challenges, how we can address those challenges. So far, we all know that what is NGC, but whoever doesn't know about NGC, so let me just give a quick information about NGC. So NGC is NVIDIA GPU accelerated hub for AI, ML, and HPC application containers, SDK tools like NVIDIA CUDA, TensorRT, Triton Inference Server, DeepStream SDK, and other third-party framework accelerated by NVIDIA. Like that, which helps for faster access to performance and enhancing software. So this is NGC offering. Now, to align with this NGC software offering, NVIDIA just started a program called NGC Ready Server to enable ecosystem to easily deploy and run NVIDIA GPU optimized AI and machine learning software on any system manufacturer hardware for high volume, low latency inference. So Lanner, we have already Lanner qualified our hardware with NVIDIA as NGC Ready Server, as you can see it over here. So we have a small form factor hardware, and we have a rack mount hardware as well. So which is NGC ready. So what has been done to make this hardware NGC ready? So Lanner has passed extensive suites of tests for validating the ability to deliver high performance and stable running NGC container on our hardware itself. So for NGC software stack, there is a base suite, and we have validated that base suite. On top of that, we also gone through hardware reliability tests, such as thermal and PCI qualification tests, bandwidth and GPU direct compatibility test, etc., to make a reliable GPU server. And we also followed some best practices to configure this hardware, such as CPU core count and CPU speed required to support discrete GPUs, system memory and storage required for that, and other manageability and security module. So we incorporate all this component in the hardware itself to make it NGC ready. So I would like to quickly introduce Lanner NGC Ready Server called LEC2290E, which is an award-winning server, and we got Best in Show award by Embedded Computing Design during latest Embedded World Conference. And just to give some information about key features of this hardware. So this hardware, the Edge AI server, can support up to 8-core CPU, 1 Tesla T4 discrete GPU, support up to 64 gig memory, and it has also inbuilt support for out-of-band manageability and security with help of TPM and IPMI modules. It has a rich expansion option, and it also comes with the various IO options, such as 4 integrated PoE, various USB ports, digital input-output ports, etc. And what are the value props of this hardware? So this hardware is purely built for Edge AI. And as I mentioned, this is NGC Ready Server. which helps our partner and customer to bring this solution as soon bring this solution to market as soon as possible. So it offers lower time to market and lower time to solution option. It has built-in security and manageability, etc. So these are the various value proposition of this hardware. So to support AI ecosystem, Lanner has various programs, and I would like to showcase what are the programs we have. To support this program, we started this initiative called AI Starter Kit. So this AI Starter Kit is actually a hardware with pre-configured system components. So the hardware comes with the CPU, memory, storage, GPU, and power adapter. So it's a pure starter kit, and this kit comes straight out of our factory. So which helps to reduce down configure to order time. So it reduces down the lead time for the delivery of system. And we are offering this AI Starter Kit in 2 programs. The first program is called AI Startup Incubation Program. In this program, we are giving this AI Starter Kit at a discounted price for startups, so they can get this hardware, work on their early prototypes or POC project, and this hardware straight comes from Lanner. The second one is called System Sample Program. This is purely for our enterprise customer. So if our partners or customer working on large scale project, we give loaner unit to our partners or customers, and then they can work on the validation and sanity check of the software if they are planning to use as a solution to scale it further. So these are the various programs. If you're interested to know more about this program, feel free to reach out to me or any Lanner sales rep, and you'll get more information about it. So I think we have a limitation on time, so I'll pass it to Abhinav to discuss more about retail edge AI use case. So Abhinav, over to you.
All right, thanks Malik. What is checkout free technology platform? If higher level, we break it into kind of 4 steps. We allow our shoppers to enter using different kind of methods. It could be credit card, mobile app, palm reader, any one of those. It could be campus card, just giving them more flexibility, reducing the friction at that step. The second part is once they authenticate themselves at the entry, our cameras are tracking these shoppers in the store as they move from one camera to next camera, as they pick items, or as they're looking at certain items and maybe not picking. So we are kind of computing, we're inferring the shopper behavior in real time. They pick some items, so we also kind of looking into product recognition, what they picked, if they put back, what they're doing. So from shopper's point of view, they just shop in the store. And once they leave the store, our system kind of knows when they have exited, and they will get a receipt in their app after their exit within a couple of seconds. What makes all this possible? It's a combination of deep learning, computer vision, and sensor fusion. And next slide, we'll look at what our architecture looks like and what are the different pieces that makes it happen. So in this architecture, you will see some of the elements that Malik discussed earlier. For us to make it work in a seamless manner, we divided our architecture in a way that bulk of processing, even machine learning, happens at the store itself. There is no server room. So these are IoT devices that we manage and monitor from our cloud. However, why we do machine learning at the edge? So that we don't have to, we can keep the data right in the store, right? We don't have to stream all the feed to the cloud in real time. So we have machine learning at edge. We use NVIDIA GPUs for inference there. And then basically the inferred output goes to the cloud, where we do another level of sensor fusion as well as machine learning to figure out what exactly the shoppers have taken from the store. And then it goes to the payment processing so that receipts can be generated, their accounts can be charged. We also provide pretty well-defined third-party APIs, so our customers, these retailers, can interface with our system. In next slide, we'll look into a little more detailed information about what ML problems we are solving here. In general, what we are solving is who took what in kind of a store, right? So we are looking at multitude of problems. Detecting person, it's a person and not a dog, not a card, right? We are tracking that person across the store as they are moving from one camera to next. We are looking at the activity recognition, product recognition, product tracking, re-identification, because you are wearing a hoodie, you may take it off. We are trying to figure out whether it's same person or not. Pose estimation, gesture, noise, anomaly, like sensors could be noisy. We need to figure out whether they're behaving right, whether they're gonna go bad in some time. So we are using ML in multitude of these problems. In our architecture, we made a conscious decision to do bulk of ML inferencing right at the edge. Why did we pick that? First of all, these are the retail stores. These are physical stores. They do not have heavy network bandwidth. So it helps us cut down on the network bandwidth itself. For example, we require more like 10 Mbps. Small stores, even lesser. And if we had to stream all the feed to the cloud, that won't be enough. It also helps with latency. Given that we are doing heavy lifting right in the store, we can generate receipts much faster. In case network goes down, network is not reliable, that's usually the case for the physical stores. They don't have dedicated line. It still helps us because all the data is being processed right in the store, and only the metadata goes to the cloud. So as soon as network is available, cloud can receive the metadata, generate the receipts without adding further delays. Also helps us with data privacy, because all the video feed stays in the store and it's not going to the cloud. So in kind of a data privacy conscious environments, for example, Europe, this architecture helps a lot in that way. And of course the cost, because the network bandwidth, if we had to require that everything has to be processed in the cloud, it will be pretty expensive for us, for the retailer to push all this data, and of course us as well. On the machine learning at the edge, we in general have cameras, sensors, and that goes through inference. And that's where we use NVIDIA GPUs like T4 and kind of NGC Ready Server for edge AI that Malik talked about. That's on the retail side. We are available here if you have any questions. In case you want to reach out to us, our contact is available on this slide. We'll be happy to hear from you. Thank you.
Thank you so much, Abhinav. And thank you everyone thank you again for joining our talk today, and looking forward to collaborating with you all. Thank you. Have a great day.